Here, we'll show you how to draw a ray diagram for a concave lens. A concave lens is thinner in the middle and thicker on the top and the bottom. Here is the principal axis drawn through the middle of this concave lens. The positions of the two focal points are shown here. These will usually be given to you. Here is the object we'll use for this example, a yellow arrow. In this case, we are looking at the object through the lens from the other side. We'll start by drawing a vertical line straight through the center of the lens like this. Next, we'll draw a horizontal line from the top of the object straight to the center of the lens. This must be parallel to the principal axis. It is important to know that concave lenses make rays diverge or spread out, rather than converge. So this ray will not extend to pass through the focal point on the right. That would be converging rather than diverging. Because rays are diverging or spreading apart, we know that this ray will be bent upward rather than downward. We'll extend this ray temporarily just to show that it is bent upward. But we don't know the exact angle it will be bent by. In order to find out, we start by erasing the extension that we drew. The angle that the purple ray is bent by the lens is determined by the focal point on the left side of the lens. What we do is draw a dotted line from the focal point on the left to the point where the horizontal purple line hits the center of the lens, like this. And we'll extend this line upward from this point with a solid purple arrow. The solid portion of the purple line now shows how this ray travels from the object to the lens and is bent upward by the lens. To help us find where the top of the image will be, we draw a straight line from the top of the object through the middle of the lens. Rays passing through the middle of the lens are not deflected. Our brain assumes that this purple ray is coming to us straight from this point. This point is where the green ray coming from the top of the object and the purple line that seems to be coming from the top of the object cross. So this will be the top of the image. The bottom of the object is sitting on the principal axis. So the bottom of the image will appear right here on the principal axis, directly below the top. Now that we know where the bottom and the top of the image will be, we can draw the image in. Because two solid rays, or actual rays, do not cross at the top of this image, it is a virtual image rather than a real image. We see that in this case, the image is smaller than the object. It is important to remember that when we view an object through a concave lens, that no matter where the object is placed, the image will always be smaller than the object. We'll review what we found here by comparing the image with the object. First, as we saw, the image is smaller than the object, and this is true no matter where the object is placed. We also see that the image is on the same side of the lens as the object, between the object and the lens. For a concave lens, the image is always between the object and the lens, no matter where the object is placed. We also see that in this case, the image is upright rather than inverted. It is also important to know that whenever an object is viewed with a concave lens, the image is always upright, no matter where the object is placed. Lastly, the image formed in this case is virtual. In fact, the image formed by a concave lens is always virtual. To review these points again quickly, in a concave lens, the image is always smaller than the object. The image is between the object and the lens. The image is always upright and always virtual.